Hi everyone. I'm audible, and has the lecture started on the YouTube? Uh, okay. Hi guys. Okay, so this is the third lecture on number theory, and we'll be going over some basic theorems and then showing some practicing some ZIO problems to go over how we can actually attack them and see how ZIO number theory appears on ZIO. So, welcome to the third lecture in this series. This will be the last lecture of the number theory module. This will be the third and last lecture. Though you have the test tomorrow, this will be basically the conclusion of the lecture series. The ZIO training series is a part of the ICO Learning series run by CodeChef and Unacademy. As ZIO is the first stage of the computing Olympiad, this is the first stage in the series. Now, as you may know, ZIO is a four-problem question paper where every problem has three subparts, and you have to give out the output in the respective cases. The questions are very algorithm based, and mostly just test your informatics-based intuition and don't require much theory. So the qualifiers of ZIO will then get to appear for INOI. So about me, I'm a 12th grader from New Delhi. I've cleared INMO and APMO. I'll be teaching you number theory as this is the last lecture. I've taught the past two as well. And also I'll be covering the ad hoc advanced modules. I hope all these lectures help your preparation and you will enjoy these series. Now we can start. Give me a thumbs up if you're ready for this lecture. All right. So as you may have seen in the outline, today theory will be very light. We'll only be going over Legendre's formula and chicken McNugget theorem. After that, we'll go over some past ZIO problems. Three of them are solved, which I have written the proofs of, and two I'll ask you to try them on your own, and I'll guide you as you work through them. Then we have the same resources as yesterday. Yeah, it's fine. Don't worry. You're on time. Okay, so today's lecture you don't again need much of prerequisites again. Okay, I'll show you the index once again. Please wait. So today you don't really need much of prerequisites again, but again I'll be assuming familiarity with modular arithmetic. The first 20 minutes or so we'll be finishing up with the theory part of today, and the rest we'll try to work on the problems. After which I'll be available for about 10 or 15 minutes for general questions about ZIO. I do not plan to discuss the solutions of the problem set here, as I have said before. I held two sessions on the Discord server, and I'll probably be holding a few more. If you want to discuss the problems, you can come there, or just you can DM me on Discord itself. Uh, Again, I'll just show you the table of contents. Theory part is just Legendre's formula and chicken McNugget theorem, and past ZIO problems are listed as listed there, and then we have the recommended resources. Okay, so this is Legendre's formula. Have you seen this before, or do you understand what this says? Do you understand what this says? Okay, so for completion, I'll just explain it to you. So VP, okay, sorry, let's switch a color. Okay, VP of A is the largest power of P such that is equal to K implies P to the K divides a, comma, p to the k plus 1 does not divide a. So this is what VP of a means. This is a very common notation. It's called the periodic notation. VP is it's not actually called V. It's new, but for convenience, we'll just call it V for now. Okay. Okay. So now the theorem states that in n factorial, the biggest power that of p that divides n factorial is this sum. Okay. Sorry. This is sorry, slightly uncomfortable for me to write it this way, and so on, where this is the floor function. Uh, I think it is streaming. Can you check once? Can someone confirm if it's streaming well on YouTube? Okay, awesome. So now with this in mind, we'll try to prove this theorem. So the proof idea is actually very simple. So let's say AI, okay, is the number of numbers less than n such that p to the I divides k. We are not saying that vpk is equal to I, but we're just saying p to the I divides k. So now you can see that AI will be a floor of, okay, I'm very sorry, n by p to the k. Because these are just, this is the number of multiples you have, less than n. Now, then Vp of k, I, must then be ai minus ai plus 1, because remember that p to the k, I plus 1 does not divide. So we can define bi this way, such that Vp of k equal I. So our final answer, okay, as I defined Vp earlier as well, I just defined it. Vp of A is defined such that is defined as k, such so p to the k divides A, but p to the k plus 1 does not divide A. That's what mu of p or pp means. So this is bi. Now observe that the final power which of n factorial which divides is b1 into b1 plus 2 into b2 plus 3 into b3 and so on. So it's 1 a1 minus a2 plus 2 into 2a2 minus 2a3 plus 3a3 minus 3a4. Observe that every term gets cancelled like this. It will subtract 1 from here and just 1 will remain. 2 will subtract from here and this would be 3a3. So just 1 will remain. So you get that the answer is actually summation of ai, which is just summation of n over p to the I floors, which is this. Let's go over an example now. So let's say we want to find what's the greatest power of 3. So we want to find v3. Okay, I'm sorry. v3 of 20 factorial. So how will we find this? We have that the answer is from a theorem. Okay, I'm sorry, I don't understand what the issue is. Why it's behaving this way? 20 by 3 का floor plus 20 by 9 floor. Others, please address these questions. I'll address these questions after the lecture. Plus, all these remaining terms will be like 20 by 27 floor, which are all zeros. I'll ignore them. So plus 0. This is 6. Okay, I have no idea what's happening here. And this is 2. So our answer is 6 plus 2, which is 8. Okay, I have no idea what's happening. I'm very sorry. Okay, so is this clear? Okay, great. So now moving on, we have we have a second theorem for today, which is the chicken McNugget theorem. It's also called the Frobenius coin problem, but chicken McNugget theorem sounds nicer. Okay, so we again have two numbers, A and B, such that their GCD is 1. Now we claim that AB minus A minus B is the largest number which cannot be written in the form AX plus BY, where X and Y are non-negative numbers. Remember in Bezout's theorem we had that we could write numbers as AX minus BY, where X and Y were non-negative. Now we have AX plus BY, where X and Y are non-negative. So X and Y, this is written as natural plus 0. So the set of naturals plus 0. Now we consider this. How do you think we can approach this problem? Just type your ideas in the chat once. How do you think we could approach proving this theorem? If you wanted to prove this, how would you prove it? Any ideas work? Just try. Okay, how would you use Euclidean division lemma here? Trial and error for all A and B. There are infinite values of A and B. That doesn't seem like a technique you can use for a general thing. Trial and error works for concrete values, not for abstract structures like this, at least in such problems. Just guess. Uh, while others think about it, I'll just give a brief introduction of what has happened till now to the ones who have just joined. Yeah, uh, yeah, two variables. So we are just discussing this. We just covered Legendra's formula, which calculates the power of p that divides n factorial, and now we are covering the chicken McNugget theorem. You can look back at Legendra's formula after the lecture. It won't be necessary for now. Okay, that's great. I didn't know that. Okay, so what we'll try to show that we can find all numbers bigger than this. So let's say without loss of generality, W log means without loss of generality. A is less than B because the case where A greater than B is also same. So as we showed in Bezout's theorem, we can write any number in the form Ax minus By, where Y is less than A, right? So we can now say let the required number be we want be K, where K is AB minus A minus B plus something. The remaining thing we can write as BQ plus R. Now if we write BQ plus R where Q and R are non-negative, so at least one of them will have to be greater than 0. Then only K is greater than AB minus A minus B. And R is one of this set, sorry. 0, 1, 2, 3. Now let x naught comma y naught be a solution to ax minus by equal r. That comes from Bizart's theorem with this condition. Sorry, that's just bad. So yeah. Now observe that if I replace x naught with x naught minus 1, and if I replace y naught with a minus 1 minus y naught plus q. So observe that this number, this value is strictly greater than 0, strictly greater than equal to 0. So this becomes a valued solution to ax plus by equal k when k is greater than ab minus a minus b. So we are done. Is this fine? Okay, now we want to show that ab minus a minus b doesn't work. We cannot find ab minus a minus b in this form. So what we do? So we just say that, say we could find a solution. Now we consider this equation mod b. Mod b, we'll get that ax is congruent to minus a mod b, because ax plus by is equal to ab minus a minus b. Here the left side is ax mod b, the right side is minus a mod b. So we get that x is congruent to minus 1 mod b. So x has to be at least b minus 1, because it can't be minus 1 as x is non-negative. Similarly, because of the same argument with mod a, we get that y is greater than or equal to a minus 1. So ax plus by is greater than ab minus a, because a into b minus 1 plus b into a minus 1, which is 2ab minus a minus b, which is greater than ab. This is a strict case, sorry, which is greater than ab minus a minus b. Thus we cannot write ab minus a minus b in this form. There's a more detailed article on AOPS which you can check out after the session. It's linked in the PDF, which will be available to you on Unacademy. It will be added to the YouTube in the description, and you can also find it on the Discord server. Is this fine? Is this okay? You can just give a thumbs up if you understand. Okay, awesome. Now these are two corollaries which I won't be going into, which I won't be proving right now, but these are things you can try proving on your own. Also, both of these are proven on the AOPS thread, so you can check that out as well. So we can actually show that for any integer k, one of k or ab minus b minus a, this is a minus b minus k, which is the same thing, cannot be written in the form ax plus by for non-negative xy. We can show this in fact for any integer, that exactly one of these we can't write in this format, and the other we can. Using that, we can show this, that exactly a minus 1 into b minus 1 over 2 natural numbers can be written in this form for non-negative x comma y. These both have very nice results that you should definitely try proving. And do you understand the statements of these results? Uh, Cannot, of course, cannot. If you, I can, I'm just in the first corollary 1, I'm just saying this is cannot. Someone asked can or cannot. I just said it cannot. Uh, I just say that exactly one of the integers k or ab minus a minus b minus k, we won't be able to write in this form. The other we will. Observe that this value is odd. No, this is correct. This is cannot only. I mean, if you change it to can, I can just pick arbitrarily large x and y, and I get infinitely many numbers which can be written in this format. We care about the numbers we cannot write in this format because large enough numbers we can just write. Here I am saying that exactly k, one of k and ab minus a minus b minus k cannot be written, so the other can be written. So one of these will be we can write, and the other we cannot. This is randomly, and either of these can be true. Don't go by these symbols. Okay, do you understand what the corollaries say? Okay, great. Now we'll try this ZIO problem from last year. I don't. This year's ZIO is called ZIO 2021 because it's for the 2021 cycle. So this is from last year's ZIO. Uh, we want to find the maximum uh, number of steps we can do this process. So the step process is, for example, if you have numbers 6 and 2, from this I can go by dividing any one of these by 2. So I can go to 3 comma 2. Now I cannot divide 3 by 2, so I'll have to go to 3 comma 1. I'm sorry, yeah, I'm not answering that again. So we go from 6 comma 2 to 3 comma 2 and then go to 3 comma 1. Similarly, we can do this process on any two given numbers. So we want to find what is the maximum number of steps we can do so that a plus b is less than a given number. So for example, here a plus b is 8. So can we improve this? Yes, we can. We can change the starting pair to 4 comma 4. So that goes to 2 comma 4, then goes to 2 comma 2, then goes to 1 comma 2 and 1 comma 1. So that's 4 steps. So we want to find how many maximum steps we can do for any given S. How do you try to approach this problem? Yes, okay. So what Tejas says is correct. No, we have to continue till we can't divide any number by 2. For example, here it's 3 comma 1. So 3 is not divisible by 2, so I can't go any further. We can only divide 1 in a step. We can only divide once in a step. Okay, so let's see what do you want me to repeat, others? Yeah, so how many can you do? And what is the maximum you can do? If you pick A and B correctly, what's the maximum can you do? You can do. Okay, so let's see what Tejas said. Where's the slide? Oh, okay, sorry. So this is the slide only. So Tejas says that we can consider the power of 2 that divides A and B. So say A is equal to 2 to the k into L, where L is odd, and B equal 2 to the j into m, where m is odd. So it will take us k plus L steps. That's what we claim. Can we show this? How do you show this? That if these are the numbers we start with, it will take us this many steps. Sum of product of powers of 2. What do you mean? Oh, that sentence makes no sense to me. I understand. Okay. So, how do you prove this? Yes, sorry, this is J. My bad. No, but how do you prove that that's the maximum you can do? You can't do any more steps, and you'll always do that many steps, regardless of the order. There's a formal way to write. I know that you get it, but how do you write it formally? Abhinav, the question is very direct. If you're given two numbers A and B, the process is that you can divide any one of those by 2 if it is divisible. You can do it for a certain number of steps. Oh, okay. So I'm saying let A be 2 to the K into L, where L is odd. Odd. Okay. Okay. B equal 2 to the J into M, where M is odd. So the maximum number of steps that the actual number of steps that I'll do on A comma B is K plus J. How do you prove that? Yes, I get it. Like you intuitively get why that's true, but what's the formal way to write it? I'll explain the formal way to write it. The formal way to write it is you say that the number of steps is V2 of AB. Now we can now observe that in every move that V2 of AB decreases by 1, and we can continue, and the process only stops when V2 of AB equals 0. So the number of steps is V2 AB. Yeah, I mean that's intuitively very true. But how do you formally write it? That's the question I was still asking you. You're completely correct, Arjun. Intuitively, I get why that's true, but how do you formally write it? This is a way to write it. So now we consider the pair AB, which has the minimum sum if we are considering the same number of steps. So now we can assume, because we want the minimum sum, that we can assume that there are no odd factors of A and odd factors of B other than 1. Because if we remove any of them, we'll end up decreasing the sum of A and B, and the number of steps will remain the same. So now we are left with A and B are powers of 2. But again, we can just assume that the K is greater than or equal to L, and also K minus L can't be greater than or equal to 2, because then I can reduce K by 1 to 2 to the K minus 1 and increase L by 1. This reduces the sum and preserves the number of steps. So we found a better pair in a sense. So all our numbers are of the form 2, 2 to the k and 2 to the k plus 1, or 2 to the k and 2 to the k. The first one happens when 2 to the k plus 2 and s is between these two numbers, and the other happens when s is between these two numbers. So you find that the answer is 2k when s is like this, and 2k plus 1 when s is like this. Do you understand what we just did? Uh, okay. What part was confusing? I'll try to re-explain that. Okay. So I hope you understand like how we got that A and B are powers of 2. Okay. Now, if we can, without loss of generality, let's say the k is greater than or equal to L. But if k minus L greater than equal to 2, we can change the values of A and B so that they're still powers of 2. Their sum decreases because the new sum is decreases by 2 to the k minus 1 and increases by 2 to the L, which is so it reduces because 2 to the k minus 1 is greater than 2 to the L. And the number of steps stays the same. Earlier it was k plus L, it's still k minus 1 plus L plus 1. So that's still k plus L. So we managed to reduce the sum of the numbers. And as we assumed earlier that we are considering the pair AB which has the minimum sum. If there are multiple pairs which require the same number of steps. That always helps us if we reduce the sum. It never harms us. Thus, we can assume that the numbers are of the form 2 to the k and 2 to the k plus 1 or 2 to the k and 2 to the k. When does this type of pair occur? You can ask yourself that. For that s must be greater than the sum, right? So s must be greater than the sum of these two numbers. Uh, Abhinav, you didn't give an answer. Abhinav, you didn't even give an answer. You just told why we can assume powers of 2, which we already did. So the we no see the thing is we want to keep the sum less than equal to s. So if we can reduce the sum, say in some case we were getting a higher sum, and we can keep reducing the sum with the same number of steps, we can say that's the maximum. Sorry. For example, if we had say the sum is bounded by a, let's say 12 for now. Sorry, let's say 10 for now. I can take the pair 8 comma 2, which works very well. But I can also take the pair 4 comma 4. This is 2 to the 1, this is 2 to the 3. I kept this number same, like the number of steps same, but I reduced the sum. This is summing to 8, whereas those were summing to 10. So I reduced the sum while keeping the numbers same. So I can actually say that this is the maximum I can do because I can't improve anymore. Others number I could improve to these, but this I can't improve any further. So the numbers are either 2 to the k and 2 to the k plus 1 or 2 to the k and 2 to the k. In which case can we go for either of these? We can just analyze the sum. You have to only write the answer. So in each case we consider and we get these as the answers. So you just have to check where s lies and output and give 2 to the k or 2k or 2k plus 1 accordingly. Okay, I think everyone got it. We'll move on to another problem. How do you think you can approach this? Where is L? Oh, that's the floor function. So for example, floor of x is the largest number, which is less than x and is an integer. So floor of 1.5 is 1. That's not true, Arjav. That's not the answer. Yeah, greatest integer function. Yeah, that's the floor function. Okay. So for example, no, but many of these can have the same value, right? For example, let's say we start with number 7. When divided by 1, we get the value, well, 7. When divided by 2, we get the value 7 by 2, so 3.5, which is 3. On dividing by 3, we get 7 by 3, which is 2. Now, remaining will all give us 1. So we actually got one number, two number, three number, four numbers. So in this case we got four numbers. So what for any number n, what is a distinct how many numbers will we get here in this set? That's the question. So let's try for another number, I guess. Let's say we want to check for 5. 5 gives us the value 5, then it gives us 2, and then it gives us 1. So only three numbers. Sorry, just one. So it only gives us 3. Like this, for any n, how many values will we get? So how do you think we can approach this? Uh, I don't understand what you're saying. Okay, what if I tell you uh, the number is, let's say the number is 50,713. I give you this number. What's the answer? What's the answer in this case? You can't do it by brute force. Uh, that's just not possible. On You have to do it by hand, so you just can't do this. And even if you do it by computer, the complexity will be too high uh, for your answer to actually work in a contest. Yeah, that's true. If the number crosses n by 2, so the remaining will be 1. But how does that help us for all numbers? Like you still have n by 2 things to consider. That's a huge set. Right. So let's start with a claim that if we consider n by I, where I is greater than root n, then the floor of n by I will be less than root n. Right? Do you understand why this is true? If this is true, does everyone understand why this is true? Okay. So we, we see that the value must be in this set. Uh, Abhinav, I'm just saying that okay, see, n by I is greater than floor of n by I. Okay, I don't know why this is not working. Now this is less because I is greater than root n. greater than equal to root n, this becomes less n by less than equal to n by root n, which is in fact less than equal to root n. Right? This much is true. Do you understand why this much is true? Or equivalently, why this is true? Okay, great. So this value, the value of this, must be in this set. Now, can I claim that every value of this set is achievable? In fact, I can. Let's see how we can do that. So we claim this, that there exists a k such that floor of n by k equal b if b is less than equal to root n. So by Euclidean division lemma, we can write n equal bq plus r, where r, I'm sorry, this is like q, this is q greater than equal to b. I'm very sorry for that. Because we have b is less than equal to root n. So we get that q is greater than equal to b and r is less than b. Because q is greater than equal to b and r is less than b, q is greater than equal to r. So when we take n by, sorry, again this is a typo, this is n by q. So when we take n by q, we can actually see that it is b plus floor of b plus r by q. And this part is less than 1, so it's equal to b. Now we claim that if x and y are in this set and x is less than y, then floor of n by x is greater than floor of n by y. And in fact, both of these things will have different, most importantly, if one is greater than the other, how did you find that by hand? If one is greater than the other, then we'll obviously get that both are different. You found that by hand, or did you know how to get the answer of this problem already, or did you solve it right now? Yeah, you knew how to solve it, right? Yeah. So that's not very helpful. Okay, so how do we prove this claim? We can say that let's assume that n equal x q1 plus r1 and y q2 plus r2. No, obviously q1 is greater than q2 because greater than equal to q2 because x is less than y. So both are also greater than equal to floor of root n because x and y are less than equal to root n. So we get that this is greater than equal to y and this is greater than, this is actually strict, but that's kind of irrelevant. So if we have q1 equal q2, then this would be true. Because you can just take both from different sets. This one comes here and this goes here. We'll have x q1 minus y q1 equal r2 minus r1, which is less than y, and this is again less than q1. But because x is greater than y, this is true. Sorry, q2. Anyway, thus we get floor of root and distinct values. Now we have found two different sets which each give us floor of root and distinct values. But do they have overlap? Maybe both of these sets have floor of root n, but we are getting something like this. We are getting one value floor of root n in both sets. So we have to consider when this case is true. If this is true, we must have this. Thus we'll be able to remove one value because it occurs in both sets. So our total number of values will become 2 of floor of root n minus 1. And if this is not true, this is actually plus 1 here, then we'll get 2 of floor of root n values. So we can actually write both of these things together in this way and remove the case. because 4 of root n square plus root n plus 1 actually becomes 2n plus 1 whole square when we do this. Do you understand how we got to this? Now, whatever your values were in paper, okay, let's just check again. I don't know. I just took a random value from my head and told you to find it. Uh, Abhinav claims that the answer for 50,173. Oh no, this is not invulnerable. Come on. Is 446. 50,100. So he claims that this plus 1 root and floor minus 1 is equal to 446. So you want this to be 447. This is what? 200,692. Oh, you got till here. Did you get till here? Okay. So I wrote out both of these things together because say if we go multiply both of these cases by 4, so we have 4n plus 1 and add 1 is less than equal to 2 of 2 floor of root n plus 1 whole square. That's how I can write this case. And then I just take the root and I take the floor and I subtract 1 because I wanted 2 of floor root n minus 1 values. Because, yeah. So you can just, I'm not going to root this, come on. Okay, I'll do it, whatever. It's 447, right? 447 squared 452. Let's see, 2025. Yeah, this seems right. This seems correct. Okay. Yeah, okay. I have calculated in ZIO. Awesome. I forgot that. So yeah, I can't show you my okay, show you calculator, but I'll just check once. Root of 200. The answer is 446. Okay, awesome. Uh, no, you don't get options. You just have to output the integer. You will actually have values given, and for example, right now I just asked you to find a general value. You will be given values of n, and you have to find for each of those. Yeah, you were correct. Sure. Yeah, calculator is there, but for function calculator only. You can actually check by using the DigiIon website. Now this is the last problem solved example we'll be considering. This is the second problem of ZI 2090. I'm not going to read through this for you. You'll just, this is a whole problem. I'll give you what it briefly means because there's too much story to parse through and it's too verbose. So we'll just get to the main content. We are given A, B, and C, and we are given N and K. We want to find minimum of x plus y plus z, where x, y, z are non-negative integers, such that this is true. So in our first case, we have uh, n equal 114 and k equal 23. So the difference is 91. And we have 6, 11, and 15. A minus 1, B minus 1, C minus 1. So we want 91 equals 6x plus 11y plus 15z. Now remember the modular arithmetic training we have done. So first we consider both sides mod 3. What do we get? We get that 1 because this is 90 plus 1 1 is congruent to 2y mod 3. Thus, at least we get that y is greater than or equal to 2, because y is equal to 2 mod 3, this tells us. So we can remove 11 twice from both sides. So now we consider the new equation that we get, mod 5. The new equation we get is, what we have 69 mod 5x, that's 4, of 6x mod 5 is x, 11 into y minus 2, because they have removed 11 twice, is just y minus 2, and 15z mod 5 is 0. So we get that this is true. The x plus y minus 2 is 4, 9, 14 or larger. Now 4, you can easily see that 9 would be too large of a number. So we consider that the case where x plus y minus 2 is 4. Now we must have the remaining numbers as 15, right? Because we have considered all 11s and 6 are there. So we want 6x plus 11y minus 5. This value, if we have x plus y minus 1 equal 5, can take any value from 30 to 55. So we want to, find the minimum number of 15s that we can subtract from 80. So resultant is less than or equal to 55, which is just 2. So our answer is 91 equals 6 plus 11 into 5 plus 15 into 2. And this is the minimum we can do, which is, in this case, it's 1 plus 5 plus 2. So our answer is 8. Is this fine? For the others, let's go over this problem quickly so we have more time for the walkthroughs. Yeah, Arjun, let's do that. Let's discuss it later. Brute force is hard because if you actually want to prove that you cannot actually get 7, and we don't want to do the mistake that we somehow forgot a case. So if we can conclusively be sure that we did not forget a case, then that's way better, because you do not have options in ZIO. Yeah, taking all possible combinations, that's a ridiculous time constraint. You can, if you can possibly do that in ZIO, but that takes too much time. This took us, when I was trying to write this up for, when I was considering the problems I can take, this took me 5 minutes, because less than 5 minutes, and I did it in my head because I could just do it this way. I can just take modulus and I'll be done. This is a basic type of Diophantine equation where you don't have to spend much time. It's just a mod bash. In the second case, again, removing the story, 76 minus 9, 6, 14 and 15. So 67 equals 6x plus 14y plus 15z. Again, we consider mod 3. We get that 1 is congruent to 2y mod 3. So y is in this set. But obviously 5 into y is just greater, 5 into y, 5 into 14, if y is at least 5, is greater than 7, is greater than or equal to 70, which is greater than 67. So we must have y equal to. So we are left with this case, where 6x plus 15z equal 39, which is just saying 2x plus 5y equal 13. And this, considering mod 5, we immediately get a unique solution, x equal 4 and z equal 1. In fact, this equation can be satisfied in a unique way. There is no other way you can even write it. So your answer is just 67 equal 4 into 6 plus 14 into 2 plus 15. So our answer is 6 plus 2, 4 plus 2 plus 1. So our answer is 7. The last case, we have 138 minus 10, 8, 11 and 25. So we have 8x plus 11y plus 25z. So immediately let's just consider the number mod 11 and remove the 11th thing. We'll get what? This becomes minus 3x and this becomes 3z, because 22 plus 3. So we have 3z minus 3x is congruent to 7 mod 11. So we in fact get z minus x is congruent to minus 5 mod 11. So because we get that z minus x is in this set, we can't, we can, obviously cannot have z greater than equal to 6 because that is too large. So we'll have z minus x equal minus 5. So we'll get x greater than equal to 5. So we can now immediately write 88 because we can remove the 5 x's, and we get, because x equals z plus 5, I wrote x equals z plus 5. I took out the 8 into 5 and subtracted it. So I get 88, which is 128 minus 8 into 5 equal 8z plus 11y plus 25z. So I divide both sides by 11. 8 equals 3z plus 2y. And we want to minimize the value 2z plus 5 plus y. I'm sorry. Oh, that's just intuition, right? It's not a standard approach. I just looked at the values and thought what seems best here, what seems easiest for me to approach. Here, I could just easily remove two terms directly as soon as I considered mod 3. So that would leave me with a very good constraint on the remaining term. Here, if I consider mod 11, it gives me a very nice constraint on the remaining term again. It will take about half an hour more. Now, as we get this and we want to minimize 2z plus 5 plus y, we consider the different values that we can take for xyz. We are only left with 3 sets, and of course the minimum is at 7 plus 2 plus 2. Our answer is 11. Because 6 plus 5 plus 1 is 12 and 5 plus 8 plus 0 is 30. Okay, is that fine for everyone? Is that fine? Let me just make sure it's fine for everyone, because now we'll be heading into unsolved examples where you have to actually find the solution on your own. Okay, awesome. Uh, can you try this problem? This is ZI 2019's first problem. Many of you may have different solutions. I'll try to guide you through mine, and if you can tell me yours, that would be awesome as well. Uh, could you please try it now? Just try it right now. Whatever comes to mind, try it. And just tell me what your ideas are when you look at this problem. You have to try to solve this problem. Whatever ideas you have, tell me. Any idea works. Okay, I'll try to give you a hint. Uh, let's say that the number of special sequences that end in n are an. Then, can we find the value of an for all n? Oh, the problem just states that you have some sequence and we call it special if like every term divides the next term and all terms are different. So how many sequences we have where the largest number is less than k, less than equal to k? Yes, but yeah, but how do we find, wait, why? I'm saying that the number of sequences am. How is am and am plus 1 related by factors? I'm not saying less than equal to m, I'm just saying m. How many sequences end in m which are special? What's the tree method? Not for large values, let's just try to find it for small values. No, not necessarily. You could just have the sequence like 1, 3. Your sequence can be anything. Like it can be 1, 3, 6, 80, 30, and so on. It doesn't need to be powers of 2. Like they divide each other, but don't need to be close or anything. What is AI in k equal 15? Uh, yeah, like that's irrelevant, right? For calculating AI, the value of k is not relevant because I'm just saying how many special sequences end in AM. So if m is less than 15, we are good to go, right? We'll have to sum up all the sequences which end in numbers less than equal to m. Okay, do you know why a of 1 equal 1? Because the only sequence is 1. The only sequence you have. Now, can you claim this? Try to show this. This is very important. That a of m is 2 to the n if m equal p to the n, where p is a prime. So for example, if the number is 3 square. Oh, okay, I see. I see also. Uh, when m is a power of a prime, for example, if it's 3 square, so how many special sequences end in this? I claim that if it's the power nth power of a prime p, then we have 2 to the n sequences. How do we show this? Okay, let's see. Uh, you consider the set. Okay, it's not, I don't know what you're saying, but I can just tell you directly. Say the set is 1, all the factors of m are in this set, right? And see that if ai divides ai plus 1 and ai plus 1 divides ai plus 2 and so on, every term divides the terms after it. So all the terms can just be powers of p and so on. And we obviously have to pick p to the n. So the remaining terms are from this set where last term is p to the n minus 1. Now picking any set of values from this. How many ways are to pick any set of values from this? There are 2 to the n ways because every term you can pick or not pick. So say if you pick some set 1, p and p cube, then a valid sequence is 1, p cube, pn. And so on. Do you see what I just did? So I directly get that if m is a power of p, then the value of n is 2 to the n. Is this fine? Why 2 to the n minus 1? You can have the individual set p to the n as well, right? If you pick nothing, then this is also valid sequence. So you don't need to remove this case, Ritesh. Okay. Now prove that when M is a product of two primes or P into Q, then A of M will be 6. Okay, so how do we do this? Let's say we only consider the case where we don't have the number 1, or let's assume we have the number 1, because if we remove it we just double our cases. The first number is 1 and the last number is PQ. You want to place, you want to multiply it in some way. Either you multiply it directly by PQ, or you multiply it by P, then you multiply it by Q, or you multiply it by Q, then you multiply it by P. Those are three cases, and you double them because you could have just removed one. So 3 into 2 is 6. This is fine. For example, let me take an example. Say M is 15, which is 3 into 5. So we consider the sequences which have the number 1 and 15. These are 1, 3, 15, 1, 5, 15, and 1, 1, 15. And I can remove 1 from all of these. So 3 cases into 2, which is 6. Now consider P square Q. You can show that AM is 16. Try this please. Any idea on how you can show this? Yeah, take your time. Okay. Yeah, I said the NT3 test as well, and that's not today, that's tomorrow actually. Uh, it opens at 8 a.m. tomorrow. You can try it anytime, but it is from 8 to 11. Yes, okay. So again, we just assume that 1 is there because we can double the cases if 1 is not there. So we have to reach the number P square Q. So how many ways are to reach it? Either we multiply by PQ, sorry, either we multiply by, sorry, either we multiply by P square Q, or we multiply by PQ and P, or we multiply with P, Q and P, or we multiply with P square and Q. Now you can see if we multiply by P square Q, this, yeah, you can do it that way. You can do it the DP way. Yeah, that's precisely what I'm doing in a way. So this is 1, this is 2, 3, and 2. So our values are 8. So 8 doubles to 16 because we could have removed 1. Now that we have these four results, observe that any number less than k is of one of these formats for our case, because less than any number less than 22 is one of these formats. So you can just find the values directly. So you can just get this set and then sum, whatever sums you want. So you will be done. You can actually get a general formula for this just based on prime factorization, which isn't very hard to compute, or you could go the DP way, of course. Yeah, there's one more problem after this. Oh, this sequence is just the sequence of AN, like A1 equal 1, A2 equal to, A3 equal to, A4 equal 4, A5 equal to, A6 equal 6, A7 equal to, A8 equal 8, A9 equal 4, A10 equal 6, and so on. Yeah, this could be done through DP. You can check the CodeChef editorial for that. The official solution on CodeChef editorial is via DP. For that works for larger values as well, but I think this is much more convenient when you're doing ZIO. Okay, this is the last problem we'll be discussing today. What do you mean 4 comes before 2 in the special sequence? This is not a special sequence. I'm just saying these are the values of an for every n. This is a1, this is a2. Sorry, this is this sequence. This is the, okay, let's say this is a. This is that sequence. Okay. Yeah. This is the last problem we'll be trying today. Maybe this is a very common trope and a very common idea that you may have seen before, but still, you should try this. What's the intuition on this when you try it? How does 7 help us? Okay, do you understand what the problem is asking at least? Can you give a thumbs up if you understand the problem? Okay, yeah, thought so. You have a weight balance. So remember, a weight balance is like this. There is one pan here and just something here, which tells you which is heavier, and then there is one pan here, right? So you can place some value here, some way. You have some set of weights, right? Like for example, you can have if you go to a vegetable vendor, for example, they somehow earlier they used to have those weights like 10 gram, 50 gram, and so on. And they would weigh how much material you're getting by placing some weights here, placing some weights here, and then balancing with the thing you need to weigh. So you want to be able to weigh the weights 1, 2 till k. So how many weights do you need to have? Like how many weights do you need to have that you can weigh? Find the minimum number you need if you pick the weights smartly. No, 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 no. This question is saying, okay, for example, okay, let's ignore this. If I'm going to buy some fruits, if I want to buy some vegetables, the vendor wants to be able to weight my number to the closest gram. Uh, no, they just that is an answer, not the accurate answer. That's not the minimum number. You can do it in that way by choosing the set 1, 2, and so on, 4, and so on, but that is not the precise answer. Uh, so you want to be able to weigh weights, like how much vegetable am I taking? And that I can weigh using my own weights on by placing them on the balance scale on either side. Uh, no, it is not. This sequence works, but there is a more optimal sequence. You can find better weights rather than this. Because remember, on a weighing scale, you can place things on both sides. So, for example, if I wanted to weigh 3 grams, I could do it by placing 1 and 2 on one side and whatever I wanted to weigh on the other side. But I could also do it by placing 4 on this side and 1 gram on this side and whatever thing I want to weigh on this side. So there's a better way. Okay, so let's try this. Assume that you have k weights. Find the maximum number of different weights that you can get using k weights. Let's say that the maximum number you can get is n weights. Prove that m equals 3 to the k minus 1 over 2. I'm not even saying what weights there are, whatever it is, how many the number of numbers you can count with k weights is less than this. They may be close to each other, they may be far, but the number of numbers you can count is this much. Can you prove this? Okay, this is actually not that hard. So let's say, oh, you don't even need induction. Uh, let's say this is the weighing scale. Everything I can either, let's say I pick one weight, I can place it on this pan, I can place it on this pan, or I cannot place it anywhere. So that gives me three options for every weight. So I get 3 to the k ways of placing weights. But in one way, I didn't end up placing anything anywhere. So I removed that way. But if you place some set of weights here and the remaining here, you could have placed these here and this here and still weigh the same thing. So you divide it by half. So that's the total number of things you can weigh. Is that fine? Okay. So say I place some weights here which sum up to A and place some weights here which sum up to B. I could just move all these weights to this side and move all these weights to this side and end up with the same thing because I could just take the stuff I wanted to weigh to the other side. So I'm double counting everything. I'm counting everything two times. So I just divide it by half so that only one case is considered, not both the cases. So this is the maximum number of things I can weigh if I have k weights. So now try to prove that if the set is 1 to m, where m is this much, I can actually do it with k weights. I can find a set of k weights that actually work for this set. Yes, I'll be giving ZIO, yes. At least I plan to give it, yes. Taking, but okay, same. New Delhi. Awesome. Okay, please try to prove this. Try a set for smaller values. Like what set can you find for say k equal 2 or k equal 3? Try to find sets. Or find some nice property about this number. Uh, any ideas? Okay, considering that nobody is replying, I'll move ahead. The set, these weights actually work. 1, 3, 9, 27, till 3 to the k minus 1. These weights work. How can you show that? You show this, that whenever you have a base 3 representation of any number, you can write it as a minus b, where a and b are also in base 3, and only have the digits 0 and 1. They don't have the digits 2. So I can write any number n in this way. If you can show this, try to think why this is the same thing. Why both are exactly the same thing, try to think of that. And now when you have done this, you can directly conclude that the answer is this. Log base 3 of 2k because of this. This is our final answer. I'll leave you to do it on your own. You can try it after the session ends, or you can keep trying it right now. I hope you actually got an idea of the approach, and you can conclude from here on your own. Again, the resources are same as I mentioned yesterday. For more NT practice, do if you want informatics. Okay. So for example, I'll go over this once. Let's say our number is 5. So in base 3, what is it? It's 12, right? So you can actually write this as uh, 1, 0, 0, 100 in base 3, which is 9, minus 11, which is 4. See that the digits here are just 1 and 0 in both the numbers. I say that I can do this for any number. Whatever number you give me, I can write it in this way. And you can essentially show that this is the same thing as this. So this is our answer. Again, the same resources as yesterday, you should definitely try Project Euler. If you want easier NT practice for Math Olympiad type problems, which is more computational, PUMAC has very cute problems. IMO shortlists are of course very nice if you want proper mathematical Olympiad problems. I've heard very well of this, but I haven't really seen many videos from here. But all the reviews I have are positive. Brilliant's and Stanford's number theory collections are awesome. I actually read up a lot of my things from Stanford's collection and Brilliant's collection. Aditya's book recently published, I think within the last 10 days it was published. It's freely available on academia. I've linked it here. You can use the link from the PDF. And the presentations and these all presentations are available for you. So do use them out of the lecture if you do not understand anything. You can go through them again. So with that, I'll be ending the last lecture. If you have this is the last lecture on the number theory series. There's still the test tomorrow, but this is all for the series, lecture series. I'll I can still hold Discord sessions if you want, but you'll have to let me know for that. My Discord username is RG230403, and you can just directly ping me on the server or DM me. The test will be generic number theory. It may be slightly harder than the ones you have faced till now, but you'll also have 3 hours instead of two. None of the ideas you'll be needing for the test are things you haven't seen. Everything that will be on the test is are using ideas that you have seen or techniques that you have seen during the duration of these 3 lectures and the first 2 tests. Please do fill the feedback form, that's quite helpful. The feedback form helps me and others, especially CodeChef, curate your content and theory so that we can understand how hard it is for you, how helpful it was for you, and accordingly plan our next lectures. So, for example, if you could give me any feedback that would be helpful for the ad hoc lectures and in any future series CodeChef runs. It also helps the other instructors judge. Uh, Thanks, Abhinav, for the feedback. But if you could also give feedback for the following 2 sessions, the second 2 lectures, where that will also be helpful. My CC handle is also RG230403, but I'm not very active in the coding community or the informatics Olympiad community in general. So you won't really find anything there. I haven't participated in any contests, I think. Uh, Combi will be taken by Nilav. He's studying at CMI, and DP will be taken by Song. He's a very good informatics student from Singapore. If you have any other doubts, you can ask them now. Uh, I cannot give my contact number here. Uh, if you still have doubts, just contact me on Discord, and we can see from there. Uh, I'm in 12th, and I won't be taking JE. I'm not interested in engineering. I won't be taking JE. What is yeah, but that's fairly complicated and unnecessary. No, I'm confused between IISc and CMI and ISI. I want to study maths, not computer science, as my primary subject. All right. Any other questions or queries? New Delhi. Jason Statham joined. Thank you. Thank you for the positive feedback.